Okay, let's try this again. So unit 11 was graphing trig functions, and there are two main trig functions that we sort of focused on for most of those that unit, which was sine and cosine. Now, sine, we always said, looks like an S. Okay, and sometimes you can describe cosine as looking like a very abstract C, but a lot of times I said that it looked like sort of like a valley or a ditch, and then if it gets reflected, it looks like a ghost to me or a hill or something like that. Now, both sine and cosine have 5 critical points, starting at 0 for sine, going up to +1, back to 0, down to -1, and then back to 0. So your 5 critical points create this shape. The 3, when you go to graph it, I always think that sine has 3 on the midline, 1 up, 1 down. And those 5 critical points are coming from a unit circle with a radius of 1. And this first coordinate be 1, 0. Then we have 0 up 1, -1, 0, and 0 down 1, which you probably reviewed in the last video. But as you go around a unit circle, remember every coordinate is cosine sine. And so that's why we get these 5 critical points, because if you start at 0 degrees and focus only on the y values, it goes from 0 to 1 to 0 to -1 and then back to 0, which is what we have graphed here. And if you look at the cosine, which are your x values, your 5 critical points are coming from 1, 0, -1, 0, and then back to 1, which is exactly what we have graphed here. The domain and range for sine and cosine are exactly the same. They have all reals because these curves extend outwards to the left and to the right into infinity. And the range is going from -1 to 1 because we are discussing just a basic sine and a basic cosine. Tangent, we only did about 1 day on tangent. Tangent is very unique. I kind of think it looks like little snakes across the graph. The big thing about tangent is that you have to understand that it's undefined over odd multiples of pi over 2. So anytime you find tan of 90, remember tan is sine over cosine. So basically what's happening is cosine is negative or is 0 at 90 degrees. And so that's why we have these asymptotes happening at every odd multiple of 90, which means one tangent curve fits in the space of pi, which is why the period for tan is pi, but the period for sine and cosine is 2 pi. So when we want to find or change something's amplitude, it's essentially like a vertical stretch. So whatever number is in front of our function, that's going to be our amplitude. Now, amplitude is always positive. It represents the height of the curve. So this would obviously have an amplitude of 2. But don't be distracted on the next example. Even though there's a negative, the amplitude is still going to be 3 because at some point it will hit a maximum height from the midline, 3 above it. Frequency. So frequency is how many full cycles you will see in a section of 2 pi. So the frequency is the b value in an equation. It's the number in front of x. We use that frequency to figure out the period, which is the 1 full cycle. So that basically is like, how much space do I need to fit 1 full sine cycle or 1 full cosine cycle? So over here, it says determine the frequency, the period, and the midline for the equation, and then graph it over the interval 0 to 2 pi. So I'm going to start off with amplitude. We're going to have an amplitude of 1. 2 is our frequency, which means I should see 2, let me write that out, 2 full curves by 2 pi. That's what this 2 is telling me. And then if I use that 2, the period is 2 pi over 2, which means by the time I get to pi, I should see 1 cycle. And then by the time I get to the 2 pi, I should see my second full cycle. And then last but not least, my midline is at -3. So I'm going to start with my midline being down at -3. If you want to skip, know if there's room. No, there's not going to be room. So I'm not going to skip any lines. So if my midline is -3, I'm going to go down to -3 and I'm just going to draw my midline going across. If you want to make it a dashed line, that's totally fine. Okay, so there's my midline. When we set up our x-axis scale, we always start at 0, 0. I do 2 boxes, and on the third line, that's 90. So that each box is representing 30, 60, 90. Then we have 120, 150, 180, which is pi. Then we have 2 more lines, and on the third one, it's 3 pi over 2, which is 270 degrees, and then 2 more lines, and then on the third one, put 2 pi, which is a full 360. All right, we have a sine curve with a frequency of 2. So remember, sine looks like an S. It's a positive sine curve. It starts at 0, 0. So we're looking for 1, 2, 3, but that third dot needs to happen by the time I get to pi. So on the midline, by the time I get to pi, I should be done with my curve. So halfway is my third dot. So do, 1, 2, 3 in a row. And then it's going to hit a maximum or amplitude of 1. Now that does not mean I'm going all the way up here. Okay. Amplitude of 1 is just 1 above the midline and 1 below the midline. That is 1 full sine curve. And it says to graph it all the way out to 2 pi. So I just have to duplicate that. So again, start and stop by the time I get to a distance of pi. Halfway for sine is another line dot on the midline. 1 up, 1 down. So there we go. We have 2 full curves by the time I get to 2 pi. All right, well, what if I just give you an equation and I ask you to find the maximum and minimum without having to graph it? So remember, the maximum is the midline plus the amplitude, and the amplitude is always positive. So in this one, it's kind of sneaky and tricky. The maximum would be 45 plus 20, and the minimum would be 45 minus the 20. So ignore the negative that's in front of the equation. These are the 2 values that it will oscillate between. All right, when things are reflected, basically if it's a sine curve, it's going to hit a minimum before it hits its maximum for a sine curve. It's just going to go down first. And if a cosine is reflected, I always think it looks like a ghost, but that's just because I'm weird. All right, what if I give you an equation and I ask you to write or give you the graph and I ask you to write the equation? Well, the first thing that we have to decide is it sine or cosine? So does it look like an S? 1 full cycle, or does it look like a valley or a ghost? So if I focus on this first equation, down, up, down, that is 1 full cycle. That is 100% a sine curve. So that's going to be a sine curve, but I notice that it's reflected. And the reason why I know that is because it goes down. So it's going into the negatives first, or under the midline. So it's reflected. Next, so we figured out if it's at negative or positive. Next, maybe the amplitude is the next easiest thing to figure out. Obviously, from the midline to the highest point, it has an amplitude of 2. Then maybe count how many curves there are. So we already counted 1. Here's a second, and here's a third by the time I get to 2 pi. So my frequency is 3 of them fit by 2 pi. This one does not have a midline shift at all, so we don't have to worry about a midline shift. And luckily, we also haven't been shifted side by side, so there's no phase shift. So we can write our equation as a reflected sine curve with an amplitude of 2 and a frequency of 3. Let's practice that again. Now this time it starts at a maximum and 1 full cycle looks like a little valley here. That's going to be a cosine curve and positive. So I don't really have to worry too much about the positive part. Amplitude goes up to 3. And there is 1, 2, but by pi over 2. So if there's 2 full curves by 90 degrees, then how many full curves will that equate to be 360 degrees? Well, to get from 90 to 360, I multiply by 4. So that proportionally will make me have 8 curves by the time I get to 2 pi, to 360 degrees. So you have to sort of set up and think, okay, if there's 2 by 90, there would be 8 by 360. So my equation is going to be 3 cosine 8x. All right, let's put this all together and do an application problem. So the hottest day of the year in San Diego, Santiago, Chile, on January 1st is 30 degrees, and the coldest day is 10 degrees. Well, that sounds like a maximum and a minimum to me. So if the hottest is 30 degrees and the coldest is 10 degrees, there's my max and min. That helps me a lot to find my midline, because my midline is my max plus my min divided by 2. Essentially, I'm finding the average between the two. Well, if my midline is at 20 and the hottest it gets is 30 and the coldest it gets is 10, I hope that you agree to get from 20 to 30, that's a difference of 10. So my amplitude, you could do the maximum minus the midline, and that would get you your amplitude. Now the period is a little bit trickier to think about. If the warmest day is on January 1st and the coldest day is on July 1st. Think about that. To get from January to July, I know you're going to say 7, but it's not 7. It's actually 6 months, because January to February 1st would be 1 whole month. And so then to get to March, April, May, June, July is 6 months later. So to go from the hottest month to the coldest month is 6 months. And then to get back up to the hottest month would be another 6 months. So the period is an entire year, 12 months. If the period is 12 months, I can use that to determine the frequency. So 2 pi divided by 12 would be pi over 6. And I can write an equation now. Now we're going to assume that January 1st is 30 degrees. That's where we're going to graph it starting from. So we're going to represent that as a maximum point. So this is going to be a positive cosine curve. So a positive 10 cosine, our frequency was pi over 6x, and we have a midline shift of 20. So we know it starts at 30 degrees. By 6 months, we're at 10 degrees. 6 months later, we should be back at a warm month. So on the line, and we can draw one full cycle of the temperatures in this city. All right, what if I don't give you a graph? Can you answer some stuff about it? Hopefully. A Ferris wheel with a radius of 25 feet is rotating at a rate of 3 revolutions per minute. If t equals 0 is when the chair is at its lowest point, which is 5 feet off the ground, write a model for the height as the chair rotates in t seconds. All right, let's draw a little sketch of our little Ferris wheel over here. This is my Ferris wheel. And whee, there's my Ferris wheel. I'm such a good drawer. Okay. The radius of my Ferris wheel is 25. So if the radius is 25, okay, 25 and 25, and we're 5 feet off the ground, remember? So we're 5 feet off the ground. Here's my little box car that's getting off. Okay, what is the maximum height? Like if I rotate all the way to the top, well, this is obviously 50 plus 55, or plus 5 means the maximum height is 55. The minimum height, like when I get on the ride, is 5 feet off the ground. So we have a max height of 55, a minimum height of 5, and that should help me find the midline. Because the midline is maximum plus the minimum cut in half. So my midline's at 30. My midline's in 30 and my maximum is 55, then my amplitude could be the maximum minus the midline, and that will help me get my amplitude. So I'm making good headway right now. I am going to be getting on the Ferris wheel at the lowest point. So if I start at a low point on a graph, then I rotate around the Ferris wheel up to the highest point, and then I make my way back down to the lowest point of a Ferris wheel. That to me is a reflected cosine curve. So we have a cosine curve that's reflected. The only other piece of the puzzle that we need to figure out is our frequency. And they're giving us the information right here. 3 revolutions per minute. I need to know how long it takes for 1 revolution. So if 1 minute is 60 seconds and I cut that into 3s, then that means I have 20 seconds for one revolution. 20 seconds is my frequency. Now that's not what I'm going to use in my formula. That's the frequency. I can use the 20 seconds to figure out my, I'm sorry, that's the period. I can use the period to figure out the frequency. So the frequency is 2 pi divided by the 20 seconds. And now I have everything I need to write an equation. Y equals a reflected cosine with an amplitude of 25. We have a frequency of pi over 10x, and it's been shifted up 30 feet. All right, last example. It says to graph just one full cycle. The reason why I included this example is because if this 2 is in front of the x and it's not pulled out in front of the parentheses, you need to take out a GCF first. So let me rewrite my equation over here. Oh, I should probably say in this last example, it does say to use t. So that's my bad. This should be a t in terms of seconds. There we go. Okay, back to this one. Take out a GCF, cosine 2. If I take out a GCF of a 2, that leaves me with a pi over 2. I have an amplitude of 1, frequency of 2, which helps me figure out the period. Easy, easy. But this is finally, we get to talk about a phase shift. That phase shift is going left, pi over 2. So if our phase shift is shifting left pi over 2 or negative pi over 2, that is 90 degrees, which is 3 boxes to the left. So same scale as I told you before, pi over 2, pi, 3 pi over 2, and 2 pi. But I should also probably label to the left 90 degrees. This does not have a midline change. Amplitude is only 1, so I'm going to skip a line just so I can spread it out a little bit here. And we're talking about a cosine curve that's positive. So wee starts at a maximum, ends at a maximum, but that has to happen within a distance of pi. So I start at a maximum, shifted left 3 boxes, 90 degrees, and at the maximum of a 1, because our amplitude is a 1. And by the time I get pi distance away, so pi is 180, so 30, 60, 90, 120, 150, 180. And I hope you agree to go from negative 90 to 90 is that whole distance. Halfway is a minimum. Halfway, which is on the midline there and on the midline. So this point is on the midline, and that is one full cosine cycle that's been shifted left with a frequency of 2. All right. Bye.